Hi everyone, welcome to today's GCSE Higher Revision video. There's 19 days to go to your GCSE Maths exam, and today we're going to be focused on the topic of quadratic graphs. Now, it's a lot to cover today. We're going to look at how to plot and draw quadratic graphs. We're going to be looking at their shapes. We're going to be looking at how to sketch them. We're going to be looking at how to find their roots, how to find where the quadratic graph equals a certain value, how to find where the quadratic graph intersects with a straight line, how to find the equation of the line of symmetry, how to find the coordinates of the minimum or maximum points, and so on. So there's a lot to cover today. So in this video, what I'm going to do is I'm going to go through those things. I'm going to get you to think about certain bits of the video today, because with quadratic graphs, it's quite useful to have questions in front of you. So what I'm going to get you to do is to pause and I'm going to ask you to think about how you'd approach certain parts, and then to press play. And then whenever I finish the video, I'll show you where the practice questions are, and they'll be really useful, really useful. Quadratic graphs is a very important topic on higher, so I'd highly recommend that at the end of this, then you try those practice questions. So let's get started.
Hi, today we're going to be looking at quadratic graphs. So in this video, we're going to look at how to draw quadratic graphs. We're going to look at how to sketch them, how to use the quadratic graph to estimate roots, how to answer other questions involving quadratic graphs, and even how to find the coordinates of the minimum point, the maximum point, and the line of symmetry of the quadratic graph. So let's get started. So here's our first question. It says, complete the table for y equals x squared plus x minus 4. So we've got this table, an xy table, and we've got the values of x, minus 2, minus 1, 0, 1, 2, and 3. So can you press pause now and work out the values for y? And remember, to find the values for y, we just need to, for instance, if we have x equals 3, we're going to do 3 squared plus 3, take away 4. We're going to substitute these x values into this equation, and we're going to find the values for y. So do that now. Okay, so if I was to do this question on a non-calculator paper, what I would do is I'd take each of these values for x and substitute them into the equation. So for instance, if it was x squared plus x minus 4, I would do 3 squared plus 3 subtract 4. And then 3 squared is equal to 9, so we've got 9 plus 3 subtract 4. 9 plus 3 is 12, take away 4 would be equal to 8. So that would be equal to 8. So that's how I would do it on a non-calculator paper, and I would just work out each one of them. I'm being particularly careful with the negative values for x, because for instance, whenever you do minus 2 squared, you get 4, and then whenever you add minus 2, you're going down 2, and so on. So that's how I'd approach it on a non-calculator paper. Now, fortunately, sometimes some of the values are worked out for you, so you just need to work out the missing ones. If I was to do this on a calculator paper, I would use the table function on my calculator, and then I would type in x squared plus x minus 4, and then I'd press equals, and then it would ask me for the start and the end. So the start would be negative 2, and the end would be 3, and the step of the interval, which would be 1. And then I'd press equals, and it would tell me all of these values. And when you do that, you get, and they would be the values for y. So if you got those values, well done. Now what we're going to do is we're going to plot them. So negative 2, negative 2. So negative 2, negative 2 would be here. Negative 1, negative 4. Negative 1, negative 4 would be here. 0, negative 4 would be there. 1, negative 2 would be there. 2, 2 would be here. And 3, 8 would be there. So we've plotted our points. Now we just need to do a nice curve through them. So we're going to go down and make sure at this point here you don't go straight across, so you actually come down a little bit further and then up again, and then you just do your curve. And that's the graph of y equals x squared plus x minus 4. And if you got that, well done. And that's it. And that's how we would use an xy table to get the points and plot the points and draw a quadratic graph. Now, a few other things to know whenever you're drawing those quadratic graphs is a quadratic graph will have a line of symmetry. Because it's a parabola, here it's an x squared graph, so it's a u-shaped parabola. If it's a minus x squared graph, it'll be an n-shaped parabola, and it will have a line of symmetry. So whenever you're drawing that quadratic graph, whenever you get to the bottom, so here and here, you're going to come down and up again. It's not just going to go straight across. So that's one thing to note. Another thing to note is whenever you're drawing your curve, to do one nice smooth curve, don't feather do that. You want one nice continuous line going through them, like so. And also, whenever you're completing the values in the xy table, you may sometimes notice a pattern with the numbers. Quite often you'll notice that it may be symmetrical. So here we've got minus 4, minus 4, minus 2, and so on. And that's quite useful in terms of checking whether you think your values are correct. And that's it. And that's it. Now, sometimes you may encounter a question which may ask you for the coordinates of the turning point of the quadratic graph. So that'll be the coordinates of the minimum point or the maximum point of the quadratic graph. So this graph has got what we call a minimum point. It's got a lowest particular point. And as you can see here, it would be there. That would be the minimum point. It's what we call the turning point. So it's where the graph turns. Instead of going down, it's now coming back up again. So that's the turning point. If it's an x squared graph, it'll have a minimum point, a lowest point, like so. If it's a minus x squared graph, which is an n-shaped parabola, it'll have a maximum point. Now you may be asked to write down the coordinates of that turning point, or even to estimate the coordinates of that turning point. Now in terms of that, if we have a look, this graph is symmetrical, and it goes through 0, minus 4, and minus 1, minus 4. So the turning point will be in the middle of those. So that'll be at minus 0.5. So it'll be minus 0.5. And if we're asked to estimate the coordinates of that turning point, we can just read off where we think that height of that point is. So I think it's about minus 4.5 perhaps. So there'd be my coordinates if I was asked to estimate the coordinates of that turning point, minimum point there. If I was asked to actually work it out, what I could do is, because I know it has to be minus 0.5, because it has to be in between 0 and minus 1, so it's going to be minus 0.5, I can then substitute that into the equation. So I could do minus 0.5 squared plus minus 0.5 subtract 4. And if I work that out, I'll find the exact height of that point, which is actually minus 4.25. So minus 4.25, so minus 4.25. And they would be the coordinates of that turning point. You could also be asked to write down the equation of the line of symmetry of that quadratic graph. And if we have a look, the line of symmetry, we would go through that minimum point. So the line of symmetry for that quadratic graph, now obviously it would come back up on this side here. So for instance, it passes through -2, -2, and 1, -2. So because it then passes through 2, 2, it will also then be -3, 2, and so on, and the graph will come back up. And the line of symmetry, if you were asked the line of symmetry, would be x equals minus 0.5. So that would be the line of symmetry for that quadratic graph. Another thing you could be asked is to use the quadratic graph. So for instance, we may be asked to use the quadratic graph to estimate the values for x whenever y is equal to -3. Now remember, y is the height, so we're trying to find the values for x that will give us an answer or a height of -3. So what we can do is, rather than putting this equal to -3 and trying to solve that quadratic by using the quadratic formula or factorizing and things like that, what we can actually just do is use our graph to find an estimate. So we would go to our graph, we would find where -3 would be, which would be here, and we could draw a nice straight line across, like so. And you'll see that that straight line intersects our quadratic graph in two places. It intersects here and it intersects here. So we can then go up to the x-axis and find the values for x that would give us an answer of -3 whenever we substitute them into our quadratic. So it would be this point here, because obviously the line y equals -3 crosses the quadratic here and here. So we go up, we can read off the values for x, our estimates, and I think that's about 0.6. So we're going to go for x equals 0.6. That's one of our estimates. And this point here, we've got -1, -1.5. I think that's about x equals -1.6. They're my two estimates. So our estimates for the value of x whenever y is equal to -3 would be x equals -1.6 or x equals 0.6. There are our two estimates. Now in terms of this question, rather than being asked to use the graph to estimate the values for x whenever y is equal to -3, we may be asked to use our graph to solve the equation x squared plus x minus 4 equals -3, where they just take this part, the x squared plus x minus 4, that part of the equation, and instead of having y equals, they just write it equals to -3. So you'll know here that the height is -3, and then you can just draw the line y equals -3, like we've done, and just read off the estimates, and that's it. So that's our first question. Let's look at our next question. So this time, I would like you to press pause to complete the xy table for this quadratic graph, to draw the quadratic graph, and then after you've done that, can you then write down an estimate for the coordinates of the turning point, and then actually find the exact coordinates of the turning point. So to do that now. 8, 2, -2, -4, -4, and -2. And now we can just plot these points. So -2, 8, -1, 2, 0, -2, 1, -4, 2, -4, and 3, -2. So we get those points, and now we just need to do a nice curve through them, so it looks something like this. Okay, so we've drawn our quadratic graph, and if your graph looks like that, fantastic. And as you can see, it's a U-shaped parabola. If we were asked to write down the coordinates of the turning point, well, if it was to estimate the coordinates of the turning point, we could look at it and say, well, if this is 1, -4, this is 2, -4, in the middle would be 1.5, so it would be 1.5. And the height, I'm thinking it's about -4.5 or something like that, because we've got -4 and -6, so -5 would be in the middle, but -4.5. So my estimate would be 1.5 minus 4.5. That's my estimate. If I actually wanted to work out the exact coordinates of the turning point rather than the estimate, well, I do know that it will have to pass through 1.5, because if we've got 1, -4, and 2, -4, it's going to be 1.5 in the middle. That would be its minimum point for that turning point. So it'd be 1.5. And then in terms of finding the height, we can substitute that back into our equation. So we can do 1.5 squared, subtract brackets, 3 times 1.5, take away 2. And that's equal to minus 4.25, so minus 4.25. And they're the exact coordinates of that turning point there, that minimum point. Okay, so that's how to draw the graph. Okay, now let's have a look at how to sketch quadratic graphs, because that could actually be quite useful, particularly whenever you're doing coordinate geometry questions. So here we've got y equals x squared minus 7x plus 10, and I would like you to sketch that quadratic graph. Now, I've actually covered this previously. We've looked at this whenever we looked at quadratic inequalities. We sketched the quadratics to find when it was perhaps below the x-axis or above the x-axis and so on. So I want you to press pause now and I want you to sketch this quadratic graph. Okay, so in terms of sketching this quadratic graph, the first thing I would look at is the fact that it's an x squared quadratic, so that means it's going to be a u-shaped parabola, not an n-shaped parabola. Next, what I want to do is I want to find where it crosses the x-axis and where it crosses the y-axis. So where it crosses the x-axis, the height is equal to 0. In other words, y is equal to 0. So that would give us 0 equals x squared minus 7x plus 10. And then we would solve this quadratic. Ideally, we would factorize it and we'll get our values for x. If it doesn't factorize, you may need to do the quadratic formula and so on. You may sometimes actually find that the quadratic has no solutions, and then that actually means that it's going to be above the x-axis rather than going through the x-axis and so on. So if I was to solve this, I would try to factorize it to begin with, and we want two numbers that would multiply together to be 10 and add together to be minus 7. So I'm thinking minus 2 and minus 5, because minus 2 times minus 5 is 10. And minus 2 plus minus 5 is equal to minus 7. So we've got x equals 2 and x equals 5. So they're the two values where the graph crosses the x-axis. So that means it's going to be over here somewhere and it's going to look like this. So let's sketch that. So it passes through the points 2, 0 and 5, 0. So they're the 2 points that it crosses through the x-axis. Now we've got its shape. We know where it crosses the x-axis. Another thing to find is where it crosses the y-axis. Our y-intercept, and actually looking at the sketch here, is not necessarily the best. It sort of bumps up and down again. But we want to find this y-intercept here. To find where it crosses the y-axis, we know x is equal to 0. So we're just going to substitute 0 into this. So we're going to get that y is equal to 0 squared minus 7 times 0 plus 10. 0 squared is 0, subtract 7 times 0 is 0, plus 10 is 10, so y equals 10. So that means that this point here would be the point 0, 10, and that's it. So we've got the shape of the quadratic, we've got where it crosses the x-axis and where it crosses the y-axis, and that's our sketch. Okay, let's have a look at another one. So can you sketch y equals 2x squared plus 9x minus 5? Okay, so if I wanted to sketch this, the first thing I would do is consider its shape, and it's x squared, it's positive x squared, so it's going to be a u-shaped parabola. Now let's find where it crosses the x-axis. So if we want to find where it crosses the x-axis, we let y equal 0, so we get 0 equals 2x squared plus 9x minus 5. So let's try and factorize this. Hopefully it does factorize and solve. So if we try to factorize it, let's see what we get. So we're going to get 2x and x. And then the two numbers will multiply together to be negative 5. Now I'm thinking if we have a plus 5 here, that'll give us our 10x, and then a minus 1 here, yeah, that would work. Let's just check. 2x times x is 2x squared. 2x times 5 is 10x. Take away x would be 9x, and then minus 1 times 5 would be equal to negative 5, so that's it. So that means our solutions will be x equals a half, or x equals minus 5. And just to go through this one here, what I've done was I've put 2x minus 1 is equal to 0. I've added 1 and added 1 to get 2x equals 1, and then divided by 2 to get that x is equal to half. And remember that whenever we want it to equal 0, these brackets will have to equal 0. This one's quite straightforward. We can just say it's minus 5 because minus 5 plus 5 is 0. And in this case, 2 times a half is 1. Take away 1 is equal to 0. Or you could make a little equation and solve it like so. Just put the bracket equal to 0 and solve it, and you'll get the value for x. So that means it crosses the x-axis at minus 5, so over here somewhere, and a half over here somewhere, so let's sketch that. And this point would be minus 5, 0, and this point here would be a half, 0. So we now know where it crosses the x-axis, we've got its shape, let's find where it crosses the y-axis. Now it's going to be negative, as you can see here, it's going to be negative, and to find where it crosses the y-axis, we let x equal 0. So to find where it crosses the x-axis, we let y equal 0, to find where it crosses the y-axis, we let x equal 0. So whenever x equals 0, we would get that y equals 0 squared is 0 times 2 is 0, so that's going to be 0, plus 9 times 0 is 0, and then we've got minus 5, so minus 5, so that means that y is equal to minus 5. So that point here would be 0 minus 5, and that's it. And that's that point there, 0 minus 5, and that's it. That's our sketch, and if you got that, well done. Okay, now sometimes we may be asked to draw a quadratic graph, or we may be actually given the quadratic graph, and we've got to use that graph to estimate the roots of that quadratic equals 0. So in this case, x squared plus x minus 1 equals 0. So feel free to press pause now, draw this quadratic graph, and then use that quadratic graph to estimate the roots of x squared plus x minus 1 equals 0. So I've just drawn a curve through our points. Okay, and then the next part is to use the graph to estimate the roots of x squared plus x minus 1 equals 0. So we've got the quadratic equals 0. Now if you notice, the y has changed to 0. So in other words, we want to find where the height is 0 or where it crosses the x-axis. So if you've got the graph equals to 0, you can just find where it crosses the x-axis and think back to whenever we sketched our quadratic graphs. So if we want to find where it crosses the x-axis, we just need to look at the graph and see where it crosses the x-axis. So if we have a look at this point here, now obviously here, this graph's been shrunk quite a bit. Whenever you actually have this on a test paper, you can read off the numbers quite nicely. But I think that's about minus 1.6, so x equals minus 1.6. And here we've got a half, 6, I think that's about 0.7, so x equals 0.7. That's my estimates for the solution. So x equals minus 1.6 or x equals 0.7. So that's our two estimates from our graph. Now, if the graph's been drawn for you, you can read off the numbers quite nicely. With this one, because we've drawn it ourselves and we've done the curve ourselves, our answers may vary slightly, and that's why we may be slightly out with those answers. But that's how you'd approach it. If they've got the quadratic equals 0, you can just find where it crosses the x-axis. Okay, let's have a look at our next part. So we've still got our graph of y equals x squared plus x minus 1, so that's y equals x squared plus x minus 1. And previously in these 100 days ago videos, we looked at how to solve simultaneous equations graphically. And sometimes you may have a question where you've been asked to draw a quadratic graph, and then you might get something like this, where it says write down the coordinates of where the graphs y equals x squared plus x minus 1 and the graph y equals 3x plus 2 intersect. So we've got the graph of y equals x squared plus x minus 1. We've drawn that, or maybe given to you. And then you may need to draw a linear graph. So here we've got a linear graph, y equals 3x plus 2. So we just need to draw this and find out where they intersect, the quadratic and the linear. So let's do that. So in terms of drawing this graph, we could do an xy table, so an xy table, and then multiply all the x values by 3 and then add 2. In this case, I'm going to use the intersect and I'm going to use the gradient. So the intersect is 2, so it crosses through the point 0, 2. Its gradient is 3, so for every unit we go across, we got 3 units. So if we go across 1 unit to here, the height's 2, so we're going to go up 3, so that brings us to 5. Across 1 unit to 2, and then go up 3, so that'll bring you to 8, and then that'll bring you to 8, going up 3, and then if we go across 1 unit to 3 and then go up 3, that brings you to 11. Actually, it crosses there at the same point, so actually that's going to help us find one of the coordinates where they intersect when we draw this line. We've actually now got 4 points. Let's draw a nice straight line through them. And also the other point is point with coordinates -1, -1. So there are 2 points. The coordinates of the points where they intersect are 3, 11, and -1, -1, and that's it. Okay, let's have a look at our next question. Now, as I said earlier, sometimes you may be given a quadratic graph drawn for you. So here's one drawn for us. We've got y equals x squared minus 2x minus 4. And we've been asked to use the graph to solve x squared minus 2x minus 4 equals 2. So as you can see, the quadratic, instead of equaling y now, equals 2. So press pause now and think how you would then solve this. So in this question, what we're trying to do is find the values for x, so whenever we substitute them into the quadratic, we get an answer of 2. So that means that we want to find when the graph has a height of 2. So if we draw the line y equals 2, so I'm just going to draw the line y equals 2, it would look something like that. So y equals 2. And what we want to do is we want to find the values for x. So we're going to go down to the x-axis and read off those values. So I'm just going to blow up my graph here just to make it a bit bigger. So if I just make it a bit bigger here, just to help me look at it a bit better. So if we have a look here, we've got the graph y equals 2, so y equals 2, that straight line, and we've got the quadratic. And we can see they intersect here and here. So let's read off what these values are. So here it crosses in the middle of that square. So if we go to the middle of that square, that'll be there. And then here it crosses in the middle of this square. So we want to find this value for x and this value for x. Now let's see what each one of the little squares is worth. So from 0 to 1, each one of them is going to be 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5 in the middle and so on. So this value here, 3, 3.5, 3.6, and then it's a bit further, so it's going to be x equals 3.65. That's one of our estimates. And here we've got x equals, we've got -1, -1.5, -6, -6.5. So there are two estimates, that x will be equal to -1.65 and x equals 3.65. And there are two solutions, our two estimates, and that's it. Okay, let's have a look at our next question. So this time we've been given a quadratic and we've been asked to draw an appropriate straight line graph and to use the graph to find estimates to the solutions to this equation. Now if we have a look here, we've got y equals x squared plus 2x minus 3. So that's this part. And this part, x plus 2, is what we want to draw because we know that the y is equal to x plus 2. Because this bit's the same as this bit, the y is equal to this. So if we draw this linear graph, y equals x plus 2, y equals x plus 2, then we can find out where they intersect. intersect, and we can find the solutions. I'm thinking back to those simultaneous equations that we looked at previously. So we want to draw the graph y equals x plus 2. And we want to draw that because this part's the same, and we've got y, and that's equal to x plus 2. It's changing to x plus 2. So we're going to draw this graph. Okay, so to draw this graph, I'm going to do an xy table, so x and y, and I'm going to choose values of x, minus 2, minus 1, 0, 1. So to get the y value, we're going to add 2 to all these values. So minus 2 plus 2 is 0, minus 1 plus 2 is 1, 0 plus 2 is 2, and 1 plus 2 is 3. So let's plot these points. Negative 2, 0, negative 1, 1, 0, 2, and 1, 3. So we've got our points. Now we just need to draw a nice straight line through them. So let's do that. Okay, so as you can see, the straight line and the quadratic intersect twice. So we just need to read off this value, which should be 1.5, 1.6, 1.7, 1.8, so 1.8. That's our first estimate, x equals 1.8. And our other one here, we've got minus 2, minus 2.5. We're going to go up to the graph there. That's going to be minus 2.8, so minus 2.8. So there are two solutions, that x equals 1.8 or x equals minus 2.8. And that's it. And if you got that, well done. Okay, let's have a look at another question. So this time we've been given a quadratic, y equals x squared minus x minus 2. And we've been asked to use this quadratic and to use an appropriate straight line to find the estimates to the solutions to this equation, x squared minus 2x minus 1 equals 0. Now this time what I notice is that the equation actually differs from the quadratic we've been given. So in the one before we had the x squared plus 2x minus 3, and we had x squared plus 2x minus 3. So that was quite nice. We knew what we had to draw straight away. But in this case we don't. The quadratic that we've drawn isn't the same as the quadratic that's in the equation that we're trying to solve. But if you think about it, we're going to be drawing a straight line graph, and that straight line graph will have a particular equation, and we've got the quadratic. So the quadratic would be in the form of x squared minus x minus 2, and then there'd be a linear, and there'll be a linear equation here that we're going to draw. Now, with this equation that we're trying to solve, it's x squared minus 2x minus 1 equals 0. The right-hand side is equal to 0. So whatever this linear was here, whenever we take it away from both sides, so for instance, if it was 3x plus 7, and we take away 3x and take away 7 from both sides, whenever we do that, we then get 0 on the right-hand side, and then we're going to get this, x squared minus 2x minus 1 on the left-hand side. So this linear equation, whenever we take it away from this, the quadratic we've been given, we're going to get this. So if we want to find out the equation of the linear, what we've taken away from both sides, we could just take this away from this. So in other words, we can consider our y equals x squared minus x minus 2, what we were given in terms of the question, the quadratic, the y equals x squared minus x minus 2. We can then write down here, we've got 0 equals, and we're just going to turn this around, x squared minus 2x minus 1. And if we take them away, it'll tell us what the linear would be. So y take away 0 is equal to y. X squared take away x squared, about 0. Minus x minus minus 2x. So minus x minus minus 2x means you're adding 2x on. So minus x plus 2x would be x. And minus 2 minus minus 1. So that's minus 2 plus 1 would be minus 1. So that means it would be y equals x minus 1. We're going to draw the graph y equals x minus 1. That's what we're going to draw in this question. And just to show you that if we have our x squared minus x minus 2, what we're given, the quadratic, and we put it equal to x minus 1, that linear, if we take this away from both sides, so if we take away x from both sides, we would get that x squared minus 2x minus 2 equals minus 1. And then if we add 1 to both sides, if we add 1 and add 1, we get x squared minus 2x minus 1 is equal to 0, and that's what we're trying to solve, and that's it. So that's why in questions like this you can take your y equals x squared minus x minus 2. You can take what you're trying to solve, the 0 equals x squared minus 2x minus 1, and y you can subtract them from each other to find out the linear that you need to draw. So that would be equal to x minus 1, and that's why we're going to draw the graph of y equals x minus 1, and that'll tell us our two solutions. So let's do that. So in terms of drawing y equals x minus 1, the y-intercept is equal to negative 1. It's got a gradient of 1, so for every 1 unit you go across, you got 1 unit. So that would be there, across 1 unit, and up 1 would be there, across 1 unit, and up 1 would be across 1 unit, and up 1 would be there, and so on. And let's just get a ruler and pencil, draw a nice straight line through them. So we've drawn the line y equals x minus 1. We've got our quadratic, our y equals x squared minus x minus 2. And then if we find where they intersect each other, will be our estimates to the solution of this. So here we've got this one, this point here, which is 2 little squares to the right of 2. Now we've got 1 divided by 5 is 0.2, so we're going up in 0.2s here, so 2.2, 2.4. So x equals 2.4. Or in this case, we've got it intersects here, two little squares to the left of the y-axis. So it's going to be minus 0.2, minus 0.4, minus 0.4. So there are two solutions, our two estimates.
And that's it. So in today's video, we've looked at loads of different things involving quadratic graphs. As I said, it's one of those topics where the practice questions will be really useful for you, from drawing them to finding where they intersect with straight lines and so on. So I've put links to different practice questions in the description below, and they'll be really, really useful for you, and I highly, highly recommend them because the quadratic graphs is quite important. So in today's video, we've gone through quadratic graphs. There's 19 days to go to GCSE Maths exam, so keep up the hard work. You're doing really, really well. And at this point, I would also say be doing lots of past papers. If you're doing loads and loads of past papers, that's really fantastic, and they get you used to the styles of questions that you might encounter. But also, if you're getting certain questions wrong, be doing something about it. So identify the topic, go and watch the video tutorials, try the practice questions, ask your teacher for some help on it, and so on. So good luck, you're doing really well, and I'll see you tomorrow for the next one at 3 o'clock on YouTube. Cheers, bye.